Assalamualaikum and very good day for all. I am Afiqah Sukardi and this is my poster for my final year project research. My title project is Development of a Fast and Rapid Voltammetric Detection for Urinary Iodine using Cetyl Trimethyl Ammonium Bromide CTAB, Absorbed Carbon Nanotube Modified Screen Printed Carbon Electrode. Introduction. Iodine is an essential nutrient for both human and animal. Iodine deficiency disorder (IDD) might interfere with thyroid hormone synthesis, cause a metabolic decline, and result in long-term brain damage. It has been recommended to monitor the prevalence of iodine insufficiency using the median urinary iodine (UI) excretion level. The current approach for urinary iodine determination based on the standard Korthoff reaction, which use arsenic serum for color-changing reaction. The use of dangerous chemicals such as arsenic is less favorable, which can affect health and safety, and prolonged exposure may lead to cancer. Additionally, this method requires a longer preparation time compared to electrochemical sensor or biosensor. Biosensor method using electrochemical detection and will detect reduction of iodide based on spike current when there is a changes of the voltage potential. It is more accurate, stable, simple, and faster. It also has the capacity to be worked on turbid biofluid, have great detection limit, and can do so with small analyte quantities. The use of cetyl trimethyl ammonium bromide CTAB and carbon nanotube CNT helped in this method development study. Objective. There is two types objective. A. General objective to develop an electrochemical sensor detection of urinary iodide using cetyl trimethyl ammonium bromide CTAB, absorbed carbon nanotubes modified screen printed carbon electrode CTAB CNT SPCE. B. Specific objective. 1. To determine the absorption of CTAB towards carbon nanotube modified screen printed carbon electrode CTAB CNT SPCE for iodide detection. 2. To obtain the electrochemical detection of iodide in urine using CTAB CNT SPCE. 3. To optimize the extraction and concentration method for iodide in urine using the modified CTAB CNT SPCE sensor. Methodology. A. Workflow of entire experiment. The flow starts from the experimental design. After the experiment has been designed, the test is carried out with a selection of the human urine that is reevaluated from the CDC result. Then, standard working solution and sample preparation is done. A total of 200 microliters of symptomatic urine and human urine is taken and used for the next step, which is the digestion sample. Please see column B, digestion sample. The urine was mixed with HCl CTAB solution, then deionized water and standard iodine 10 ppm were added. The mixture is mixed well and the test is carried out. Please see the flowchart A again. Analysis was conducted with biosensor potential start metron drop send use stat 400 and the human sample result were compared with the validation result from the CDC. The last step is the result where the calibration standard and spike sample of the symptomatic urine show the correct and significant value. Result and discussion. Standard calibration. The graph showed that the UI concentration was consistent with the reduction signal microampere, resulting in a linear graph with the equation y equals to negative 0.0023x plus 0.0396. The coefficient of determination R squared show a good value of 0.9978%. LSV signal was clearly observed that the higher the iodine concentration, the higher the peak high produced. Consequently, this calibration standard graph was accepted and could be used. Refer figure 1a and 1b. For spike symmetry urine, spike on low level show with a percent recovery of 94%, which fall into the very good category. This indicates that the biosensor machine and the method successfully detect even the lowest value. Refer figure 2. It is also demonstrated that the method of validating a matrix is compatible with a specific method and was successfully carried out. The LSV signal results show the spike for both standard and synthetic urine were accurate and consistent as expected, and significant results were successfully obtained. For human urine, LSV signal on color like green, red, and dark red show large curve that shifted to the left of the calibration standard, blue color. This show iodine on both sample was exceeded the actual standard calibration value. The signal pattern in spiked human urine suggests that there may be other interference in the sample affecting the iodine signal reading. Therefore, it is likely that human urine sample require a digestion method to clean the sample and enhance the signal for accurate measurement. Please refer figure 3. Acid digestion. For the standard calibration of acid digestion, red signal, no peak graph is generated. Refer figure 4. Regarding the spiked urine sigmatic yellow signal, human urine sample light green and spiked human urine dark green. The resulting pink indicate a shift to the left from the calibration standard graph and this suggested interference in the sample, likely due to the carryover from the acid use or other interfering elements affecting the biosensor voltage reading. This indicates that the acid digestion for the test was unsuccessful. For base digestion, last LSV signal in figure 5 show trend on the peak formation. To ascertain the acceptability of this trend, the second peak situated in the middle and the rightmost peak are compared together. Upon the comparison, it appears that among all set of peaks generated, there is no correlation relationship or trend in concentration position. The resulting pink signal light stem from the interference with the sample or other element or carry over from the base solution itself. As noted in prior research, interference substance in base solution can significantly impact the detection of urinary iodide. Conclusion. As a conclusion, this method is suitable for iodine detection analysis using a biosensor. However, it is still required further exploration of the digestion method for human sample so that this method can be established and used in worldwide. Acknowledgement. We are grateful and sincere thanks to my SV, Mrs. Nurkhairu Baria Baharun, and my co-SV, Mr. Muhammad Azrul Azri Jamilan, for the guidance and encouragement to finish this project. Thank to IMR for allowing me to use the facility to carry out this project and those kind people journeyed together during this research. And this is my references. Thank you for listening my poster presentation.